Hello, everyone. Today's lesson is a refresher on a skill from Algebra 1, and it is graphing systems of linear equations. So I want you to think back to what a system really is, and we'll define it in a moment, but it's this idea of actually looking at two lines on one graph and being able to say something about the relationship between the two, particularly what the solution means. So to help us kind of really jump into this with both feet, we're actually going to start by looking at this real world scenario. And the title of it is, Will the Women Catch the Men? This information is about the income bracket earnings by gender. And by bracket earnings, we're saying percent of men earning between this much and this much, between 50,000 and 74,999, and so on. The percent of women earning between these two values. That's what a bracket means. And we're looking at the years 2002 to 2005. It says here, the scatter plot shows the percentage of men and women earning between $50,000 and $74,999 since the year 2000. So 2000 is our 0 year. A line of best fit has been drawn through each set of points. So what this is saying is that these ordered pairs don't make a perfectly straight line because it's not a linear relationship, but we can model these points with a straight line that goes through as many of the points as possible. So that has been done for men and women. If I were to figure out which is which, if I look here, 220, 220. So that means that the red line is men, and this black line is women. I figured that out by looking at my points. 2, 20 is on the red line. That came from 2, 20, which is the men. Or I could have looked at 2, this is somewhere between 15 and 16, about halfway, 2, 15.5, 2, 15.5. All right, first it says define variables. So it's nice when I have a table because I can just literally look at my axes. Here's X, here's Y. So X is the number of years since 2000, and Y equals percent earnings. Percent earnings. Find the approximate point of intersection for the two trend lines and label the ordered pair. So the point of intersection is exactly what it sounds like. Where do these two lines intersect? So I'm looking at my two lines, right there. There we go. That is my point of intersection because it's where the two lines intersect. And if I were to look, we go X is 8, and then up 21, 8, 21. We've labeled the ordered pair. Now question 3 asks us to interpret the meaning of the point of intersection. So if I were to bring the ordered pair down here, 8, 21, this is where looking at our labels really helps. I know that X is the years since 2000. So 8 years after 2000, and then my Y value is percent earnings, percent of men and women earning between that much money. If we were to write this as a sentence, now that I have an idea of what's what, well, I know 8 years after 2000 is 2008. So in 2008, men and women, actually we should add 20, before we write that, we should say in 2008, the percentage. So the percent is 21. 21% of men and women So in 2008, 21% of men and women earned the same, that's the key word there, the same bracket earnings. In that year, both men and women earned between 50K or 50,000 and approximately 75,000. Before 2008, women earned less and men earned more. After 2008, look what happened. Men are in a lower bracket and women are in a higher bracket. It was in this single year that earnings were the same. Now that our minds are warmed up with this idea of finding where two lines intersect and then actually analyzing its meaning, let's talk about some important definitions. A system of linear equations from last year, again, prior knowledge, when two or more lines or linear functions are graphed on the same plane. When two or more linear functions are graphed on the same plane. So for example, applying that to this one, how many lines are here? 1, 2. That's 2. That automatically makes this a system because I have more than one line graphed on this plane. Now the solution, this is key, the solution of a system of linear equations is where the two lines intersect, also known as point of intersection. So this would be a good place to pause if you need to catch up on the definitions or on the real world sentence that supports number 3. Go ahead and pause, and when you're ready, we're going to start looking at some practice. So a system is when I have two or more linear functions. A solution is where those two lines intersect. Let's dig into some practice. So for number 1, I have a system because I have two linear functions. We really are going to rely on all of our prior knowledge from all of our refresher days in Unit 2. I'm first going to identify M and B. So as a reminder, y equals mx plus b, where b is my y-intercept. This is what I'll use first. M is my slope. I'll use that second. So for example, in number 1, this first equation, m is -3/2, which means down 3, right 2. And b is a +2. Let's take one line at a time. Okay, we're just going to graph this first line. So I use my intercept first, b equals 2. So I go to 2 and I plot my point. Now we're going to use our slope to count. Down 3, right 2. Down 1, 2, 3, right 2. Down 1, 2, 3, right 2. Down 1, 2, 3, right 2. I want to get as many points as possible in both directions. So I went down 3, right 2, down 3, right 2, down 3, right 2. I could have done the opposite. This negative could be associated with the denominator. So the opposite of this would be up 3, left. So from my y-intercept, up 1, 2, 3, left 2. Up 1, 2, 3, left 2. Go ahead and take out your ID or your piece of paper folded in 4s or a ruler, a straight edge of some kind. Let's get a nice straight line happening here. Arrows on both ends, and we're halfway there. Let's go and identify the same information for our second line. Here, m equals 1/2. which would mean up 1, right 2, and identify B, which is 6, positive 6 right there. So we're going to use this piece of information first, B equals 6. So I go 1, 2, 3, 4, 5. I'm going to put this in a different color. 1, 2, 3, 4, 5, 6. There's my starting point. From here, I'm going to follow my slope, rise over run, vertical change over horizontal change, however you like to see it or think about it. I'm going to count up 1, right 2. Now, I could keep counting this way, but notice I'm looking to intersect with that other line. So it's great I got a point in this direction, but I'm like, man, I want to go the other way. So I go back to my intercept, and I count down 1, left 2. Bam. There's my point of intersection. Let's get 1 or 2 more points. From here, down 1, left 2. Down 1, left 2. Take my straight edge. Nice, neat line. Nice and neat. Arrows on both ends to indicate that this is a line. The solution is this point of intersection. So to count that, remember, ordered pairs are x comma y. So from my origin, I'm going to count left 2. So that's negative 2, left 2, and then up 1, 2, 3, 4, 5. Negative 2 comma 5. And we're done. Let's practice with number 2. Process does not change. Identifying our slope for the first line, I checked, is it solved for y? Yes, it is. So right away I can say m equals 2/3, which means up 2, right 3. B equals negative 3. Let's graph this line first. I realize I didn't stick with my colors. Okay. Let's graph this green line first. So I use this piece of information first. I go down, 1, 2, 3, there's my y-intercept. Following slope for directions, up 1, 2, right 1, 2, 3. Up 1, 2, right 1, 2, 3. We want to get as many points as possible for the first line. I can't go up 2, right 3 again, so I go back to my intercept. The opposite of up and right, down and left. So down, 1, 2, left, 1, 2, 3. I can do it again. Down, 1, 2, left, 1, 2, 3. And get our straight edge. Let's graph our line. We want arrows on both ends to indicate that it goes forever and ever. Let's switch over to blue for me. Blue line, y equals 4, 6x plus 2. I'm in good shape. It's solved for y. So I can identify m equals 4, 6, which means up 4, right 6. And then B equals 2. Just so we can keep these separate, I'm going to move this up. So we're going to graph B equals 2 first, which means I go to 2 on my y-intercept. 2 on my y-axis is my y-intercept right here at 2. We're going to count up 1, 2, 3, 4, right 1, 2, 3, 4, 5, 6. Can't count anymore this way, so go back to your intercept and do the opposite. The opposite of up and right is down and left. So down, 1, 2, 3, 4, left, 1, 2, 3, 4, 5, 6. Let's get our straight edge. What is sticking out as interesting to you about these lines? When I look, these clearly will never, ever, ever cross. They are, what do we call these? Parallel lines. Parallel lines. Parallel lines will never cross, which means we will never have a point of intersection, making our solution no solution. No point of intersection ever, ever, ever. And if I look at the slopes, we could actually reason that out, because if I can reduce 4/6, both are divisible by 2, that actually reduces to 2/3. So notice we really did have the same slope all along. This just hadn't been reduced. So parallel lines, no solution. Very good. Looking at number 3, when I look here, both are solved for y. That's nice. Right away I can say m equals 1/2 here and b equals 1. This will be up 1, right 2. Let's plot this one first. So up 1 for my intercept. My y-intercept is at 1. I'm going to count up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And then the other way, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Woo, lots of points. Look how nice this line will be. Let's get your straight edge going. At any point, go ahead and pause. If you're like, oh, I can finish this one, go ahead and pause right here and you finish the graph and see if we match our answers. For my second line, m equals 3/6, b equals 1. In terms of directions, my slope will be up 3, right 6. So I plot my y-intercept at 1. I'm counting up 1, 2, 3, right 1, 2, 3, 4, 5, 6. Interesting, I'm right on the line. Go back to my intercept, down 3, 1, 2, 3, left 1, 2, 3, 4, 5, 6. So this, in fact, is one line. See if I can make it obvious. This is a little thicker than I want, but one line directly on top of the other. Imagine this red line was a little skinnier, but I'm trying to make a point here. It's one line right on top of another. They're the exact same line. If I didn't want to make it with the big chunky marker, the way that you could indicate that with yours is to put another set of arrows. That indicates, again, see how I have this double arrow effect going? It means one line is right on top of the other. That means that these lines intersect everywhere. These lines intersect everywhere because they are, in fact, the same line, the same exact line. So if they intersect everywhere, that means infinitely many solutions. Infinitely many solutions. Number 4, we have special case where one of these is a vertical line, one of these is a horizontal line. When you see y equals a number, I really want you to imagine that this actually said y equals 0x minus 4, because that's what we have here. We have our slope is 0. It's going to be a flat horizontal line. My intercept is at -4. So I go down 1, 2, 3, 4, -4, and I draw a horizontal line through -4. X equals 3, this is undefined. This will be a vertical line. So I literally say x equals 3. So I go 1, 2, 3 on the x-axis, and we're going to draw a vertical line through that point on the x-axis. Looking for our solution, our point of intersection, it's right here. Counting, that's 1, 2, 3, so 3, comma, down 1, 2, 3, 4. If I look, do we see a really cool connection between the solution and my equations? X equals 3, 3, y equals -4, -4. How cool. So if you see that, and you remember, if I have two special cases, it actually kind of tells me my answer. I still need to know how to do this graphing, but it's just a neat connection to see what these equations look like and what my solution ended up being. So to take some quick notes if you forgot special cases, y equals a number. horizontal line. X equals a number, vertical line. And these kind of special cases will continue to pop up as we work in this refresher unit. So bring that prior knowledge back. Moving on to 5 and 6, ask yourself what's different about this. Notice we're asked equations in slope-intercept form. And if I look, are these solved for y? No, 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 no. So my goal is this. I need this first before I can graph. So we're actually going to take these two equations and write them over here first because we have a little work to do. That's what this space is for. To solve this for y, we're going to subtract x from both sides. Y equals negative x plus 8. There's 1. Go ahead and pause and work on this one by yourself, and then we'll compare answers. I'm going to subtract x from both sides. I get negative y equals negative x minus 2. I know I'm not done because I see that negative 1 out front. Remember, this negative represents a negative 1. So we're going to divide each piece by negative 1. And we get y equals x plus 2. So now that I have both in slope-intercept form, I can actually go ahead and identify m equals negative 1, b equals 8. Remember, this as a fraction would be negative 1 divided by 1. So down 1, right 1. Let's do one line at a time, okay? So looking at that first one, b equals 8. 1, 2, 3, 4, 5, 6, 7, 8. Let me just check. 1, 2, 3, 4, 5, 6. Yep, b at the top. I'm going to go down 1, right 1, a bunch. Remember, the more points we get, the better off we'll be at finding our point of intersection. So just keep going down 1, right 1, literally as many times as you can. And graph that line. Arrows on both ends to indicate that it's a line. A quick check, I have a negative slope here, so I should have a decreasing line. I'm in good shape. Now for my second line, m equals 1. Again, 1 as a fraction, 1 divided by 1. So this will be up 1, right 1, and b is 2. So I go to 2, and I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. When you hit the point of intersection, feel free to circle it. Make it stand out. Up 1, right 1. As soon as you hit it, maybe just 1 or 2 more points will do. And then we can draw our nice, neat line using our straight edge. Arrows on both ends. Our solution, 1, 2, 3. So 1, 2, 3, 3, comma, up 1, 2, 3, 4, 5. 3, comma 5. Right there. Well done. Same idea for number 6. I check nowhere near having slope-intercept form, so we're going to take them and write them down here and solve. So 2x plus y equals 1. Let's do this one first. Go ahead and pause. You solve it, and then we'll compare answers. So we solve the first one. We should be getting y equals negative 2x plus 1. My slope is negative 2. My intercept is 1. We'll use the intercept piece first. So I go to 1 on my y-axis, I plot a point, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. The opposite of that would be up 2, left, up 2, left, up 2, left 1. And we plot our line. Nice arrow on both ends. Our second equation, y plus 3 equals negative 1/2 times x plus 4. Go ahead and pause. My hint to you is we're going to distribute negative 1/2. Pause and give it a shot. So when I distribute negative 1/2, negative 1/2 times x is negative 1/2 x. And then negative 1/2 times 4 will be minus 2. To wrap this up, we'll subtract 3 from both sides. Negative 1/2 x minus 5. It's nice to put our final answer in a box. I meant to mention that before. So identifying m here, m is negative 1/2. So that'll be down and right. And b is negative 5. Let's see what the graph looks like. So I go to negative 5, 1, 2, 3, 4, 5. Down 1, right 2, down 1, bam. There's my point of intersection. Down 1, right 2 again. I could do a couple more points this way if I wanted to. I don't have to. As soon as I get my point of intersection, I'm in good shape. Let's draw our line. Again, neatness is key. Use that straight edge. To count the point of intersection, we start at our origin. We go left or right first. So I go right. 1, 2, 3, 4. 1, 2, 3, 4. And then down. 1, 2, 3, 4, 5. Ooh, let me try. 1, 2, 3, 4, 5, 6, 7. 4, negative 7 is what I got for that point of intersection. And I check. These are both decreasing lines. And if I look, negative slope, I should have 2 decreasing lines. So if your graph didn't come out right, check. By accident, did you somehow end up with an increasing line? Give that a double check. Our last question, number 5, says, verify algebraically that your point is a solution. Verify algebraically, if we think back to last year, really is saying plug in your solution to both equations. So if I look, the solution for 5 was 3, 5. We already did that work. We found that out. Our 2 equations for number 5, x plus y equals 8, and x minus y equals negative 2. Going back to the originals. So we are actually going to let this be x and this be y. And let's see what happens. So this will become 3 plus 5 equals 8. 8 equals 8. Check. That one worked. That's only half of it, though. It has to work over here, too. So x is 3. So 3 minus, I'm going to put y inside parentheses because I'm subtracting, equals negative 2. 3, there's nothing to distribute. Like if I had plugged in a negative 5 here, negative becomes a positive. That didn't happen to me here, so technically I actually can just drop the parentheses and see this as 3 minus 5. 3 minus 5 equals negative 2. Negative 2 equals negative 2. Check. They both worked. I have verified algebraically that it's a solution. Now, let's say by accident I had messed up and this was a negative 5. Well, it would have failed right here. 3 minus 5 does not equal 8. So if this doesn't come out to be equal, if this side had not come out to equal 8, it would have failed. Or if this one worked, but over here, this side did not come out to equal -2, that would also be a fail. It has to work in both equations, the whole system. So if there's 3 equations in the system, it would have to work 3 times. Great job. Tonight's practice, or the practice that follows this assignment, where is it? I don't know. You have it in your packet. I'm sorry. I must not have printed it to Smart Notebook. But you'll see that the next page in your assignment says homework. So practicing our flipped classroom, that homework is actually for you to try. If you want to, you can actually get started on it now, or save it, gather your questions from today's notes. We'll start off tomorrow with a debrief on graphing systems and jump right into our practice at the start of class tomorrow. Have a great day, everybody.